So the second part of section 4.2 is simplifying complex rational expressions. So what do we mean by a complex rational expression? Well, look in 2a and see that there are 3 different fraction bars. So you never give a final answer that has more than one fraction bar. So it's considered a complex expression if it has more than one fraction bar. So we need to simplify this. And there's 2 very different ways, so I'll show you both ways. So the first way is to look for the LCD of every fraction in the fraction. So the only denominators I even see are x's. So that's my LCD. So then I would multiply what I'm starting with by x over x, the LCD over the LCD. Now the left-hand fraction has 2 terms in that numerator, so I need to distribute the x to each of the 2 terms. So that'll give me 8x plus, and then the x over x cancels and leaves me with a 1. Then in the denominator, I also have 2 terms, so I need to distribute and get 4x minus, the x's cancel, and I get 4x minus 1. So this is your final answer. Nothing cancels here. Okay, so this is the first way. Then the other way is to just look at the numerator first and get a common denominator for the numerator. So I'd have 8 over 1 times x over x plus 1 over x. So that's 8x plus 1 over x. Then I'd look at the denominator and get a common denominator for it. So I have 4x minus 1 over x. And then I would write it, the original problem, as 8x plus 1 over x over 4x minus 1 over x. So this is what the original problem is equal to. But the way we do this divide is we actually multiply by the reciprocal of the denominator. And now we do have x over x that are being multiplied. So they do cancel, and I'll get the same answer. You can't get a different answer doing it different ways. So I get the same answer both ways. Okay, so let's look at the next one. And the only denominator I see is x minus 2. So I'm going to multiply by x minus 2 over x minus 2. Well, now I have a binomial, a 2-term, times another binomial, a 2-term. So I'm going to need to FOIL here. So I'm going to have x squared minus 2x minus 3x plus 6 over, now I'm multiplying the x minus 2 times the x. So I'm going to get x squared minus 2x minus, and then just a 3, since the x minus 2's will cancel. So I'll have x squared minus 5x plus 6 over x squared minus 2x minus 3, but I really need to check and see if there are any matching factors in the top and the bottom. Well, I made the numerator by FOILing x minus 3x minus 2, so I know how that factors. And then my denominator has to be a 3 and a 1, minus 3 plus 1. Well, now I have matching factors in the bottom, so that is equal to 1, and they cancel 1, and I'll have x minus 2 over x plus 1. Okay, so that's the first way. Let me show you how I would do it the second way. So the second way, I already have my denominator ready. Sorry, my numerator. My denominator, I would need to multiply by x minus 2 over x minus 2 to get my common denominator. So I have x minus 3 over x squared minus 2x minus 3 over x minus 2. And then the way I carry out that division is multiply by the denominator reciprocal. Okay, so you see we get to the same exact math where we need to factor the denominator and cancel the matching factors because they're equal to 1 and get the same answer. Okay, so let's do one more. C, I have x over x minus 2 plus 1 over 3 over x squared minus 4 plus 1. So remember that x squared minus 4 factors as a difference of squares. And so you can see that this other denominator divides evenly into that first denominator. So this is my LCD, the x plus 2x minus 2. So I'm going to multiply by x plus 2, x minus 2 over x plus 2, x minus 2. And use as many parentheses as you need to make it all make sense to you. And I'm multiplying this entire denominator by each of these two terms. 1, 2. So the first one, the x minus 2's are going to cancel, and I'll have x times x plus 2. Plus, and then nothing cancels, so I'll get x plus 2 and x minus 2 when I multiply by the 1. Then I have that denominator times, again, 2 terms. The entire denominator cancels, leaving me with 3 plus x plus 2, x minus 2. Okay, and now for the simplifying, have x squared plus 2x, and we know this part is x squared minus 4, over 3 plus x squared minus 4. So it looks like I have 2x squared plus 2x minus 4 over x squared minus 1. So now I need to see if I can simplify anymore. So I'm going to factor out a 2, the greatest common factor, and get x squared plus x minus 2 over, we know this factors as a difference of squares. So I'm going to factor the trinomial in my numerator and see that I have matching factors of x minus 1 in the numerator and denominator. So I'm going to get 2 times x plus 2 over x plus 1. Okay, so that was doing it the first way. And let me just demonstrate doing it the second way. So I have x over x minus 2 plus a 1 in the top. 3 over an x squared minus 4 plus a 1 in the bottom. So the second way is you get a common denominator in the numerator. So I'm turning the 1 into x minus 2 over x minus 2 so that there's a common denominator. And I'll have 3 over x squared minus 4 plus x squared minus 4 over x squared minus 4. So I'm going to have x plus x, 2x minus 2 over my x minus 2. And then I kind of exaggerate how big the main fraction line is, just so I don't get confused later. Then I'll have x squared minus 1 over x squared minus 4. And the way we do this divide, we multiply by the reciprocal. And then we see what we can simplify. So I'm going to have 2 times x minus 1, x minus 2x plus 2, difference of squares, x minus 2, and x minus 1, x plus 1. So when you have matching factors in the top and the bottom, they cancel, and so you get the same answer as doing it the first way. So let me know if you still have questions.